Hey guys, today we're doing Chapter 2, Section 6, which is quadratic models. So quadratic functions are in the form ax squared plus bx plus c, where a is not equal to 0. And basically a can't equal 0 because if a equals 0, that cancels out our x squared term, which is the whole point of a quadratic function, is that we have something squared. When you have a positive a value, that means that your parabola is going to open up, so it's going to look something like this. And it'll have a minimum value. So wherever that vertex point is, that's going to be your minimum value. If you have a negative a value, that's going to open down, so it'll be a parabola that looks like this. And again, wherever that vertex is, that'll be your maximum value. Our quadratic formula is negative b plus or minus radical b squared minus 4ac over 2a. And we use this to find the zeros of the graph. Another way to talk about zeros is you can call them the x-intercepts. They're the place where the graph crosses the x-axis. It's the value of x where y equals 0. So all of those things mean the same thing. They're all talking about the zeros of your function. So let's say that I have f of x equals 2x squared minus 9x plus 3. And I want to find the x and y intercepts. Well, the y-intercept is just where the graph crosses the y-axis. So that's when x equals 0. So if I just plug in a 0 here, I get 3. So I know that my y-intercept is 3. So that one's easy to find. The x-intercept or the x-intercepts are the ones that are hard to find, and that's where we use our quadratic equation. So in this formula here, my a value is 2, my b value is negative 9, and my c value is 3. So if I plug that into my quadratic equation, I've got negative b plus or minus radical b squared minus 4ac over 2a. Okay, so when I simplify that, I've got 9 plus or minus radical 81 minus 24 over 4. 81 minus 24, that gives me 57. So I've got 9 plus or minus radical 57 over 4. Okay, and then I can try to simplify that. So 57, that actually can't be simplified at all, so I can actually just plug this into my calculator, and I'll get 4.14 and 0.363 for my two solutions. So those are my x-intercepts. So those are the places where it crosses the x-axis. Okay, we can also talk about throwing or dropping a ball. That's kind of one of our essential modeling problems when we're talking about quadratic equations. So the formula for this is always going to be the height equals negative 1/2 times gt squared plus v naught t plus h naught. And h is the height after t seconds, g is the acceleration due to gravity. If you're in meters, it's 9.8. If you're in feet, it's 32. T is our time in seconds, v naught is our initial velocity, and h naught is our initial height. So knowing that, let's try this problem here. So a projectile is shot from a tower 10 feet high with an upward velocity of 100 feet per second. We want to write an equation for the height of the ball. So first thing I notice is that this is in feet, so that means that my g is going to be 32. I'm shooting from a tower that's 10 feet high, so I know that my initial height is going to be 10. And my initial velocity is going to be 100. So I've got h of t equals negative 1/2 times 32 times t squared plus my initial velocity, 100 t, plus my initial height. When I simplify that, I just get negative 16 t squared plus 100 t plus 10. So that's going to be my equation. And then it says, how long will the ball be in the air? Well, essentially what it's asking me to find is to find the x-intercepts. So if I were to graph this, it would look something like this. Well, if I want to figure out how long the ball is going to be in the air, I need to figure out when it hits the ground, which is going to be at this point here, which is your x-intercept. So what I'm going to do is I'm going to plug these into my quadratic formula. So I've got a equals negative 16, b equals 100, and c equals 10. So I've got negative b plus or minus radical b squared minus 4ac over 2a. Okay. And when I plug that into my calculator and solve it all out, I get approximately 6.34 seconds. Okay, next up, I want to use my calculator in the table to find a quadratic regression model for the table. So I'm going to do the same thing that I did for the other linear regressions on my calculator. I'm going to go into Stat, Edit, and then you're going to enter in your x values into your list 1 and your y values into your list 2. And then if you go to Stat, Calc, you'll see something called quad reg. That stands for quadratic regression. So that's going to give you a quadratic formula rather than a linear regression, which is what we're used to. So normally we go in and we press linreg because that stands for linear regression. Now we're going to go in and we're going to press quadreg, and that stands for quadratic regression. And that's going to give you something in the form ax squared plus bx plus c. So you're just going to plug in those a, b, and c values, and then you'll have a function. Now what you should get is y equals 0x squared plus 5x plus 9.5. So you'll notice that this is actually not even a quadratic, this is just a linear equation. But this is how you find your quadratic model. Okay, that's everything for section 6.